second concentration process, right, of concentration technique, that is flotation, right, or flotation. So basically, okay, fine. So what is the principle behind the flotation or flotation? We remember on the basis of difference in their surface chemistry, right? Because some of the mineral may be hydrophobic and some of the mineral may be hydrophilic, right? In other way, I can simply say in flotation technique of concentration, we are just separating the hydrophobic minerals from hydrophilic minerals. That's all. You can simply write it also, right? Hydrophobic minerals are separated from hydrophilic minerals. And in the real situation, most of the minerals are actually hydrophilic. They are not hydrophobic. Sulfide is one of the example where it is naturally hydrophobic sometimes, right? So intentionally we are adding some chemicals to change the surface nature of the mineral to make it hydrophobic, right? So we are intentionally making the mineral hydrophobic, and once the mineral becomes hydrophobic, it will attach to the air bubbles, right? And air bubbles always moves from bottom to top of the container automatically because they are lighter, no? Air bubbles means what? Inside it is air, outside it is water, right? So it is floating and moving upward finally. And finally you can separate them, that's all. But the hydrophilic minerals, they will simply go and settle at the bottom. So this diagram is simply saying everything, you can see. So we have a flotation cell. So this flotation cell is having one agitator. This is important actually, no? Agitator, right? So agitator function is it will agitate the bath, see, or agitate the slurry here. So we are feeding the slurry from the top. Slurry means what? Water will be there and fine minerals will be there. And fine minerals means gangue will be there and your main concentrate will be there also. Available minerals and gangue both will be there together. Because our aim is to separate the gangue and concentrate, right? So this is the slurry you can see, and we are feeding the slurry from the top, and agitator is there, right? And also you can feed some water also with that also. Right? Also we are supplying some air, right? Through this we are supplying some air. Why we are supplying the air here? Can anyone tell me? What is the need of? It will form bubbles, very good. We are supplying the air so that the air will go and finally it will get released here, for example. It may get released here, right? So these air bubbles will try to escape, right? So where it can try to escape? When it will reach to the top of the surface, right? So these air bubbles will start forming and it will rise to the top. And slurry is what? Your gangue solids and your concentrate solids, valuable mineral solids, right? And water is there. And basically, for example, this is your hydrophilic nature. These taggings are actually hydrophilic nature. For example, these are hydrophobic. So your valuable minerals which are hydrophobic, they will start attaching with these bubbles, and these bubbles slowly rise up. And finally lot of air bubbles will reach at the top here. Right? So lot of floats will be there. Lot of air bubbles will be there, and when it will be very high, finally it will fall down to this. What is this called? Launder. Concentrate launder. So it will collect all your concentrates. And the hydrophilic minerals, which are gangue basically, they are going and settling at the bottom, and you can take it out to this end. Those are called taggings. It's very simple. So we need agitation, we need air also. You can write what is the need of air to make air bubbles, and agitation is, if you do more agitation, what will happen? It is a slurry now. So gangue and your valuable minerals will get agitated in there, and also it will form more bubbles. More agitation means more air bubbles will form. And one point, basically, we also add one chemical that is called Froth. I will discuss that. Froth means, like for example, detergent. Suppose you take a bucket of water and you agitate with your hand. You can see some bubbles, air bubbles will form, right? But if you add some like Ariel or any detergent, for example, into it, so more bubbles will form, right? So that means initially without any addition of detergent, when you are agitating the water, air bubbles are forming. That's fine, but it will collapse easily. But if you add detergent and you agitate with your hand, So bubbles will be bigger and lot of bubbles will form. They will not collapse easily. You can see they will stay for more interval of time. So in other way I can simply say, if you are adding some detergent, for example, into water and air bubbles are forming, so the function of this detergent is what? It is stabilizing those air bubbles so that they will stay for more interval of time. They will not collapse easily, right? So stability of the air bubbles actually depend upon this detergent here. So similarly, frother is a chemical agent. If you add them into this flotation cell, they will stabilize the air bubbles. So air bubbles can stay for more interval of time. They will not. Can you tell me why, if they will collapse, then what will happen? Suppose air bubbles will move and they will reach to the surface, right? Surface means this is air and this is your slurry. So they will stay here. So if they will collapse, then what will happen? Minerals which have come to the surface again will descend down to the bottom, right? So there is no sense of doing flotation. So that is why the main function of frother is that you can write one point. The main function of frother is to stabilize the air bubbles so that they will stay for more interval of time at the top of the ear and you can collect it. But if they will collapse, the moment they will reach at the top and they will collapse, the mineral which has carried to the top will again fall down. It's fine. Agitation, basically agitation actually it is a kind of mixing also. Suppose you are adding some chemicals. We are adding a lot of chemicals. You need to mix it. Formation is a mixing process. We are actually want to mix. Suppose I am adding a frother, right? And I want to mix the frother uniformly. If I will not do any agitation, it will not form any kind of mixing will be not proper. And also you are supplying air also, right? You are supplying air also. If you do agitation also, what will happen? Then this air will also get distributed throughout the slurry. Otherwise, air bubbles will come. For example, it may migrate like this. It may migrate like this. But if you do agitation, air will also get sprayed everywhere. You have to collect the hydrophobic minerals from everywhere, from the slurry, not from a particular point. So agitation is also required for that. And it doesn't mean you will agitate the bottom part. Because whatever gets settled at all, it will also get agitated again. So it is at the top somewhat, not at the bottom. That agitator is somewhat at the height, not at the bottom completely. Otherwise, whatever get descended at the bottom, that will also get mixed with the slurry. Fine. So I am sure you will get a question from this in the end semester. The principle and mechanism of flow flotation, and you can draw the flow flotation cell also. So fine. This is so we discuss about what are the chemicals. One is collector, second one is frother, and third one is modifier. We discuss these two today. So when we want to do Froth flotation or flotation, we need chemicals. And these chemicals, why we need chemicals? Because chemical will change the surface chemistry of the mineral, like from hydrophilic to hydrophobic, or it may increase the stability of the air bubbles, whatever, right? So all these things have some of the function, right? So one is collector, one is frother, one is modifier. Modifier, for example, we can change the pH value, dispersant, or depressant. Otherwise, you can write pH regulator. Modifiers. These are modifiers. what is a foam actually? Foam is nothing but same air bubble actually. Foam is nothing but a air bubble. That means the air bubbles is getting trapped in the liquid, or here it is in the water. No. Because when you are acidity, the moment you are acidity, the atmospheric air is also getting going into that. You are making a path actually. You are making a path. Like whirlpool, you are making a whirlpool. Something is going inside. Right? Because you are creating a pressure difference. When you are acidity, you are creating a pressure difference. So atmospheric air will go in. A low pressure difference you are creating. Atmospheric air is in high pressure now, so it will go automatically. But it will collapse. But if you add detergent, the foam will form and remain for more interval. It will not break easily. So that is the main function of Froth. Okay, anyways, we'll discuss this one in the coming class, but today we'll discuss these two, collector and Froth. Collectors are chemicals actually. They are organic chemicals. Basically, they are organic in nature. So collectors are organic chemicals which are added into the flotation state in a very little amount. And what is its function? Its function is it will go into the flotation state and it will coat some specific minerals. It will coat. There will be a coating, and the coating will be specific, selective coating. For example, there are two types of mineral. One is the valuable mineral, one is the gangue, for example. So you want to float the valuable mineral and you want to settle down the gangue at the bottom of the cell, right? So if you add a particular kind of collector, that collector will go and mix with the slurry and finally it will form a coating. A particular coating will form on the valuable mineral. But the gangue mineral, it will not form any kind of coating, right? So that means the mineral which you want to float, which you want to bring to the top, right, that is getting coated by the collectors. And why coating is required? Because collector will make your mineral hydrophobic. As I told, most of the minerals are hydrophilic in nature. They are not hydrophobic, right? So you want to make the mineral hydrophobic. So what can be done? You add collector. And you have to remember, if you are using, suppose iron ore, and you are using aluminium ore, you are using copper ore, you are using tin ore, so the collector which you require may be different for different minerals. It may not be work for the same collector will not work for every mineral. It may be different. Okay, so you have to remember this. You understood what is collector, right? So collectors are the chemical, organic chemicals which makes the mineral hydrophobic. How? Just by making a coating on it. Okay, it's very simple. So, how it will look like, for example, so this is long chain, this is long chain, this is your, for example, head, right? So this is polar and this is non-polar. This is polar and this is non-polar end. For example, this is your mineral. So it simply means that collector is made up of two components. One is the head and one is the tail. So basically, this is very interesting. This is careful. This is very interesting. The collector have two parts. One is polar and one is non-polar. Water is polar or non-polar? Water is polar, right? Dipole. Two poles are. Or I draw the diagram if you remember the structure of water, right? Because one end is positive, one end is negative. Because of residual positive charge and residual negative charge. Because of hydrogen, that's equal positive, and oxygen, it is negative, right? So water is polar. So collector is itself made up of polar end and non-polar end, right? So the moment you add collector into the flotation state, it will simply go and make a coating. It will make a coating. How it is making a coating? It is reacting actually. Some chemical reaction will happen. Preferential chemical reaction will happen between the mineral surface and the collector. So collector one end is polar, so that polar end is actually attaching with the mineral surface, but other end is free. Let's see the diagram already has drawn. So this is already mineral available in the flotation state. You add a collector at two ends. So this one end is getting attached to the mineral. And which end? Polar end. So this end is actually free. That means what you understood? It becomes now the mineral become hydrophobic or hydrophilic? Hydrophobic. Why? Because this is the free end. Now, this end is free. This end is free. That means this end is free, this end is attached already, right? So this end is free means this can be attached to what? Right? Very interesting. And air bubble wants to do what? Air bubble wants to rise to the top. Is it okay? So this is the diagram. So you can draw it. There will be a question. You can draw this. Right? So collectors have two ends. One end is polar end, one end is non-polar end. Right? Or in other way, in simple way, you can also write collector have two ends. One end is hydrophilic end, one end is hydrophobic end. So hydrophilic end will attach to the mineral surface. Because mineral is already hydrophilic. Initially mineral is hydrophilic. You want to make it to hydrophobic. So hydrophilic will attach. Right? So hydrophilic end of the collector will attach to the hydrophilic surface of the mineral. And other end will be free. And the free end will attach to the air bubbles. Because other end is hydrophobic, air is also hydrophobic. So they will attach and it will rise. Is it fine or? Very simple things. Is it okay? Or shall I repeat? Any confusion you have? You can ask. But the point is, in between them there is some other substance will be there. Can you tell me which? Just imagine. Already this is mineral, fine. This is your collector. From here to here it is collector, right? This is the mineral, and this end is your air bubble water, fine. And in between them there will be some substance. Just frother will be there. Frother, right? Your frother stabilize the air bubble. Right, so frother will also attach to the air bubble. Right, so this is the thing. So, is it fine? What is the collector and how collector works, or what is the principle behind the collector working? Yes. You can write some example of collectors. We will discuss types of collector. There are two types of collector. One is anionic, one is cationic. Sorry, three types. Anionic collector, cationic collector, and another collector is non-ionic. You can write this one. So one is non-ionic collector, one is cationic collector, one is anionic collector. Non-ionic, cationic, and anionic. Actually, it is decided by this one. Actually, this end. That means the polar end. If the polar end is your cation, right? Then it is cationic polar. If the polar end is anion, it is an anionic collector. If it is neutral kind of thing, right, non-ionic, so it is a non-ionic collector. Very simple, right? So we can write an example. In the GATE exam, sometimes they ask this kind of question related to this collector and examples. You need to match which collector is what. You can write collector example is oleic acid, oleic, OLEIC acid. So one of the example collector is oleic acid, OLEIC acid. and basically it is called tall oil. TALLOI, tall oil. As an example, you can take alkyl sulfate and sulfurate. Alkyl sulfates and sulfurate. Sulfates and sulfonates. As an example, you can write amines, diamines, and acetates. Amines, diamines, and acetates. These are all examples of collectors. You can write example of Froth. Example of Froth is pine oil. Example of Froth is pine oil. Another example is crystalylic acid. Crystalylic acid. Crystalylic acid. Third is polypropylene glycols. Polypropylene glycols. Polypropylene glycols. Last one is aliphatic alcohols. Aliphatic alcohols. So these are the example of Froth. Shall I repeat? One is pine oil. One is crystalylic acid. Third one is polypropylene glycols. And last one is aliphatic alcohols. So these are the examples you need to remember. Okay, let me tell you another point about this collector. See, I told, for example, this is a mineral. So this is a mineral. So collector will come and form a coating, as I told. This is a coating. Coating of collector. And this is a mineral. Right. So in other way you can draw like this, right? So lot of collector will come and you understand the point. See, and this mineral is hydrophilic, right? Mineral is hydrophilic. And this coating, one end is, so these end are what actually? Hydrophobic. And this end is hydrophilic. Okay. Now see what is the condition. Initial mineral surface was hydrophilic. You have added collector. Collector has both ends. One is polar and non-polar end. So polar end is complete form a coat around the surface, right? And finally this surface is free complete. So what will happen? Air bubbles will start attaching with this, right? It will attach to the air bubbles. So these are air bubbles. Is it fine? Don't imagine one collector will come and attach to one surface. They will form a coating, or many collectors will come and cover it completely. And you have to remember, this absorption of collector on the surface is either chemist option or it is physicist option. Right? The absorption of collector on the mineral surface is either physics option or chemist option. Physics option, you know these things from chemistry? Anybody remember? You remember what is the difference between adsorption and absorption? What is the difference?
एडजॉर्प्शन सरफेस में होता है.
Yeah, adsorption means if something is on the surface itself, it is not going inside, only surface contact. So basically collector is adsorbed, not absorbed, adsorbed, AD. On this adsorption of this collector on the mineral surface, either chemi or physi. Chemi-physi means chemical reaction will happen, physi means just physical bonding. So in which case you think the attachment is stronger, in physi absorption or chemi absorption? Chemi absorption is very good because chemical bonding is there, strong chemical bond, but physi absorption is very weak. So you have to remember one important point. Basically cationic collectors are physically absorbed, on the surface. That is actually physisorption, not chemi. Anionics, basically they are chemisorption. Right? You can write this is the difference also. Difference between cationic collector and anionic collector. And sometimes it happens, some adsorption may be physi, which is weaker, but they are more selective sometimes. You cannot ignore them. Listen carefully again, I am saying this is very interesting. Suppose you want a strong bond between your mineral and collector, right? Then you want a chemical bond, chemisorption you want, but sometimes what happens, they may be not selective. They may coat both gang and valuable minerals. It may happen. But there are certain collectors which may be get physi absorbed on the surface, which is a weaker bond, but they are more selective sometimes. They will simply go and coat on the valuable minerals, not on the gang. So you cannot ignore them. So you need to check many things. You should not check only whether it is getting physically absorbed or chemically absorbed. Chemically absorbed is good compared to physically absorbed because strong bond is there. But it doesn't mean you need to check also whether they are selective or not, right? Because you want to float only single mineral, not both minerals, right? So there is you can write, there is another concept you can write that is called direct and reverse. Direct flotation and reverse flotation. Direct flotation and reverse flotation. Direct flotation means if you want to float a particular mineral, for example your valuable minerals, and valuable mineral is going to the top, that is actually direct. But if you want to float the gang instead of your valuable mineral, that is actually reverse. You may get a question in the exam like what is direct and what is reverse flotation. Right. Direct flotation understood, that means you want to float the valuable mineral and valuable mineral is going to the top. But if you want to float the gang instead of valuable mineral, then it becomes your reverse. But basically which we want? Mostly we want to float direct actually, because it will go to the top and come out and become a concentrate. Okay, fine, we will continue in the next class.